Hi there, Tamas is here from Easy Automator. Nice to see you again. By today, you can learn with me how you can use the intelligent path generation function of Easy Automator. I will show you with this screen how you would be able to create a kind of zigzag or snake line which will cover the screen. Why we need this? So for coating, for grinding, for any manufacturing purposes, customers are integrating the teach pen to the manual device, what they have for manual processing, and then they are just really doing all the processing technically correct and right, exactly the same way as they would do every day for the tasks. And as a next step, you can for sure create a robot program, and after the first mimic and then teaching, the robot will take over, and the robot will continue up and complete the task with the rest of the workpieces for you. But what if not even with the first piece, I want to take my time for the coating, because this is maybe not so complicated, or this is a quite big area, and this would be basically enough if we could teach only with one movement how we want to cover with this one single movement, how we want to coat this area, but we want to cover all this area. So I will show this you by today, how we can do this. I will use the screen for this, and I want to create a kind of zigzag line starting from this corner, so from this corner coming low to this one, and then up and down and up and down and all the way until we can really cover the complete area of the screen. Okay, so for this I already prepared a RobotDK file. You can see here with in this special case with an Elite Robots CS612. I could use any kind of robot or cobot. I was just using this. This is quite a standard size of a cobot, which a couple of customers of us are using. The tool is a very easy one. This is 00200. That means this is my tool. You can see here, this is the tool. You can see this. Just wait a second and just move along the robot a little bit. So you can see here, this is the tool. It's 200 millimeter far away from the flange, but you can define with the tool definition, define TCP built-in function, any kind of TCP, what you want or what you attached onto your robot. The frame is a standard one, so here you can see the frame. I'm using the typical wooden plate with origin, X and Y coordinates. This is the way this will be my frame by today. It's not even fixed on the table for this demonstration. I don't want to hit any accuracy records. I just want to show you how easy it works. And the home position is kind of accidentally have chosen a home position by myself, and it's called J home. Okay, so then let's start. We will need 4 points. I will need 1 point for a starting position, 1 point for the end position of the line. I will need a third point to define how big the area should be, and I will use a fourth point. However, this is a kind of optional stuff, but I recommend you to do so. So you're using just the fourth point, and with the fourth point you can define the angle. With which kind of angle do you want to really do the processing later on. For the recording or definition, for the defining of the 4 points, you can use either the teach pen, or you can use with your integrated onto your manual device. I will use only the pen in this case, but you could use it as well. 1, 2, 3, and the orientation. This is up to you. I will just use it with the pen only because it's easier for me to handle. Okay, I'm just starting over the Easy Automator software. And here, this is the standard GUI. I will touch the corner points of the screen with the device, but I don't want to that I'm touching it with the later on with the spray gun. So therefore, I will apply a tool offset. So I will touch the point that I have exactly this point defined, but the tool should come only to this position. So I will define it with 8 centimeters or 80 millimeters far away from the surface. To do so, I come to the offset to tool, and the tool offset will be minus 80 millimeters. So this would be the plus direction, and this is the negative direction. If you are trouble with this, then you can always check out the coordinate systems, and this is the tool TCP what we will use, and here then you can see, okay, I want to move toward, along, or back in to the direction of the robot. So this is up to you, okay? I was just defining only minus 80 millimeters. That means I will touch the screen, but the robot in the reality will come 8 centimeters far away from this surface. All right, so we just started recording, and just normal and usual, I just have to define the origin, the X, the Y, and back to the origin for the accuracy. Okay, this is 4.99 millimeters. This is exactly on the limit. I was not taking care a lot about the positioning of the laser box and everything. So, as I mentioned to you, I want to define the first point where we will start the movement. So this is our very first point, and I will just create one single point here. The second point is, I'm just touching the screen, but in the reality, this will be 8 centimeters far away from the screen. And the second point is the end. So from this point to this point, this will be the first line. Okay. The third point is with which we will define the area. Okay. And the fourth, which I mentioned you already, oh, sorry. I just want to, that you can see here on the screen as well. Okay, this was not a good idea. The fourth point is really the orientation. So in which angle I want to hit this. So I want to hit this exactly with this orientation, okay? So that means with such a direction I want to spray it over. Okay. Now I have my 4 points you can see here on the screen, so I can finish the recording. This is the only stuff. If I would start over, if I could start over, I just send it to home position. And if I start over, then you can see here, okay, it doesn't really make much sense. Yeah. So these are just the points which we recorded. First, second, third, and the fourth point is for the orientation. We do not need this program for the further stuff. You can even delete it if it disturbs you. What we need, we have to open up the so-called Afterwork Tools folder of Easy Automator, and here we are looking for the intelligence path generating Zig-Zag. And I just start over. And there's a new, an additional user interface is coming up. Here you could choose the robot, the tool, and the home position if you would have more than one of these options. I don't have. The first question or the first input, what we really have to make, okay, how many paths or lines should be generated? So in this case, this is 4. This is the standard value. That means 1, 2, 3, and 4. Okay, this is a little bit too big, this difference for me. I want to have it approximately at 3 centimeters between the lines. So I'm not sure. I'm just coming to 20 lines. So in total, I want to have 1, 2, 3, 4, 5, 6, 7, 8, 20 lines, okay? For sure, you can calculate it if you want. You can measure your area and then you can divide it back. At this moment, the line distance, so the distance between the single zigzag lines, this is still not defined because we do not know where we will do this, but I will come later to this. An additional stuff here, you see the offset point before and after the path is the so-called approach position. That means that we are not hitting the points boom, but we will come from with the robot somewhere to the near, and then we are just nearing to this point. In this case, I was just defining 80 millimeters far away from this corner. So this here somewhere will be the first point where we will arrive with the spray gun. And additionally, I want to have 50 millimeters far away from this point. So that means the robot will come to this point, and from this is this first point, the very first point, where the spraying will be started. Okay, so you can activate or deactivate this feature. Right now this is activated. I want to still stick to the X and Y position of this point, and I want to come back 50 millimeters far away from the very first point where we will start over. Then define the prefix of the target, so the new points and the name. Just rename it with 0, 1. So right now we just have to define where we want to start the pass, and this is the first point. Where we want to end the first line, the path. This is the point 2. The point 3 is the area boundary. That means this will define how big will be the area. And once I hit this, you can see, okay, this will result 38 millimeters between the lines. Okay, I told you I want to come somewhere into this region 30. So let me say, okay. Okay, so I have to decide if I want to make 25, then I will land up with 30.1 millimeters, and I leave it so. And the fourth point is, you can see that this is really the angle. So if we take a closer look, wait a second, I just want to show this to you. You can. Okay, wait, the robot, I just deactivate that. We can see everything here on the screen. So you can see here the first point and the second, so they are really perpendicular to the surface. I don't want to have it so in a manner, but I want to have it with this kind of angle, yeah? And this defines only the angle, bam. Not the position. The position of this fourth point, it doesn't matter. It absolutely doesn't matter. It is only just the rotation, okay? How I want to have the rotation of this point. Okay, and once I hit the generate path, you will see that the first point will be exactly there where the P1 is, with the orientation of the P4. Yeah. And here you can see, so this is the starting point, 50 millimeters far away, and this is the second point where we will start our process. Okay, so how it looks like here, you can see that we were already generated a couple of points here. So that means the robot will drive at the very beginning to this point. Then we will close up to the first point where we will start the spraying, and then coming down and up and down. And to have a better visualization on this, I just can have this double click on the path, and then you can see that the robot is starting the movements which we defined 25 times. And then after the last point, he will come back exact to this position, yeah. Okay. All right. And this was the home position. Okay. So we have it here. What we can do additionally, we can add, so this is the first point. This is the first point, okay? Then this is the second one. And at the point 2, at the PG2, so the first point is this offset, is the safety offset. At this PG2, we want to add an instruction set IO in this case. Okay, sorry. So I want to have it in front of this. And this is depending on your configuration. At my robot, it is so that we have a digital output on the first channel with the value 1, and at this point with the set IO11 we will just trigger a coating gun that it will start the spraying, and then I just have to come to the last point, and then here I just add an instruction set or wait IO puff, and here I will just switch off the first channel. That means in this particular case that we will start to this first point, to the safety, then we switch on the tool, in this case the spray gun, and then we are just coming to the first position where we will start the spraying. We are just coming through so this was the safety position with the last one, and even before this we are going to the safety position. So this is the last point on the screen here, okay, and then we just switch off the piston, and then we are just getting into the safety distance. In this case the home position is too far away, so this is ideally the home position should be in front of this, because here this will result in a crash that you can see that from this point we are just coming back to this one. It is just because of this example. With a real setup where the home position will be defined by the physical robot, this will not happen. Okay, so and this is the complete program what you need in this case, what you want to export, and then you just as usual select the post processor. I'm always using the script files, and then depending on the robot what you are using, you can either use the send program to robot directly or generate robot program, bam, and then this generated robot program can be transferred via USB, FTP, or whatever connection do you prefer. So that's all with the intelligent path generation. I hope you enjoyed this video and you understood all the stuff. If not, then please leave us a comment or just reach out us via our website, and then we are happy to answer your questions. I wish you a lot of success, and bye.